Hi, this is Remy Pangle with CASE at JMU, and today we're going to be talking about the relationship between voltage, current, and power when it comes to electricity. So when we talk about voltage in an electrical circuit, sometimes in the water analogy, we talk about it as like a pressure. For me, I think about it as the potential for electrons to flow. And when we think about a potential difference or this potential, sometimes we can equate that also to a waterfall. So if we look at these two waterfalls here, one of them is very tall and the other one is shorter. So when we talk about voltage, this would be a high voltage scenario where we have a lot of potential for those water particles to fall down that tall waterfall. And this shorter waterfall would represent lower voltage. When we talk about current, in an electrical circuit, it really is just the flow of electrons, the rate of flow of electrons through the circuit. And again, you have to have a closed circuit in order for this to happen. Your power source needs to be connected to a load in order to make those electrons flow. Until you do that, you just have the potential for these electrons to flow, which is that open circuit voltage. Once you apply the load, you're going to have a current, and those electrons are going to flow at a rate. And when we bring that back to our waterfall analogy, and you look at these two waterfalls, you see that this waterfall seems to have a high flow, and it's almost like rapids. So this would be a high current scenario, and then this kind of stagnant river over here would be your low current scenario. When we put both of these things together, we have voltage, and we have current. So here again is your pressure or potential. And then this is your rate of flow. Together, those are going to give you power. So if we were going to keep with this waterfall analogy, if I showed you these two waterfalls, this is the same waterfall, but now in two different seasons. Think spring when everything is melting and lots of water is flowing versus the middle of summer where there's not a lot of water. If we were to describe these in terms of current and voltage, we would say that the voltage is the same. But this one has a higher current and this one has a lower current. So if we relate that to power, if voltage is the same, then this waterfall here is going to have higher power because of its higher current. So that's all nice. We like waterfalls, they're super fun. But with our students, it's always great to have a visual. So I will introduce you to Rocky. Rocky is my famous raccoon that demonstrates how voltage and current together will give you power. So in this demonstration, I have a small bottle of water and a larger bottle of water. And these two bottles of water are going to represent current, the rate of flow at which these are going to drop. Little water dropping, lots of water dropping. So this is low current and this is high current. Now, if I want to understand how power is going to affect my load here, Rocky is my load, I also want to be able to change the voltage. And in order to do that, again, it's that potential. So this is low potential, and if I want to change that to a high potential or a high voltage, I'm just going to hold it higher. So let's try a couple of scenarios. If we have low voltage and low current using our little bottle of water, Rocky doesn't go very far. But if we decide to increase our current and increase our voltage, he goes a little higher. So together with current and voltage, you can increase your power. Now, the best part of this is when you are in the classroom and you can stand on a chair, or you can get a gallon-sized bottle of water to demonstrate if you super increase your power. To increase your power a ton, you can increase it to a larger volume of water or larger current at a much taller height, and you're gonna fly Rocky halfway across the classroom, and the kids are gonna go wild. So again, it's important for an understanding of the relationship between current and voltage to get the power output from your wind turbine or your solar panels as you're preparing teams for the KidWind Challenge. I hope this helps. Enjoy.